Hello, everyone. I'm Jeff Bauer, and I'm going to share with you one of the most important skills that you can have as an astronomer, and that is how to write a good proposal. Um, this is an art, but it is important in many different contexts uh, for observing time, grants, um job applications in some sense. And so all of these, some of the same fundamental principles um, that I'll talk about here also apply um, for the case of writing an observing proposal. Okay, so the first thing to know, reviewers are overworked and they're not expert in your proposal. Imagine that you're an SMA referee and you have 30 or 40 proposals to read, and you might have, you're teaching a class and you're supervising students and you're trying to do some of your own research, and you're going to squeeze this in, and the reviewers are very conscientious, but they have very little time. And that means they might spend only 5 to 10 minutes reading your proposal. Um, they know the field. That's why they've been chosen as referees. They know high profile results. They'll be current in a lot of the literature, but they won't know everything about what you're presenting. And then the reality is that oversubscription means that reviewers are looking for reasons to reject your proposal, not because they have anything against you, but because they're tasked with the challenge of trimming down uh, from what's proposed to a reasonable uh, uh, program for the telescope, and that means cutting some things. So if your program is, or if your proposal is deficient in some ways, uh, reviewers will use that as part of their justification. The second thing to think about is this quote, which I really love. If I had more time, I would have written a shorter letter. Um, and I think we all know this phenomenon that the more preparation that you put in, the more knowledge you have about a subject, and the more time you give yourself to revise, the better the story that you can tell, and the more concisely that you can tell it. So know the science, know the instrument, know the proposal requirements, and that's really key. That's where many proposals trip up. Proofread, get a second reader, um, especially for people who are starting out. Um, having a fellow student or another postdoc or someone in your research group review your proposal uh, that can help enormously. And they can ask you, what did you really mean when you wrote this? And they can give you that kind of feedback that makes the results clear. Another really important piece of advice here is tell a good story. Writing proposals, writing grant applications, writing papers is a lot of that is about telling a story. You need to give context. Um, you need to give detail. We're scientists. We like to dig into detail and understand the nuts and bolts of things. You need novelty and you need excitement. You need people to come away thinking that it's worthwhile doing this. Something truly interesting might come out as a result of carrying out your observations. And of course, the context, that places it in the bigger picture of what all of astronomy is trying to do, or big questions that astronomy is pursuing. So generally, proposals tend to follow outlines that look something like this. Some context. What's the big picture? then, you know, dig into the meat. What is the specific part of that big picture that you're addressing? Don't say that you're going to solve all of galaxy evolution or star formation, unless you are, and that's great. But most likely you're not. You're digging into a specific question or problem. And then how will these observations address that problem? How can, after you've gotten your 8 hours of data and you've made an observation and you've analyzed it, how is the field going to have changed? Then you need the details. You need to be convincing that you know what you're doing. What sources are you going to look at? How are you going to observe them? What kind of sensitivity do you need? You know, can you demonstrate in some way that you're capable of reducing the data? And then it's good to have a summary statement. Bring it all back together and remind the referee, and hopefully they've made it to the end of your proposal. Remind them why you're doing this and how it all ties together. So some themes to think about. What is the narrative? Again, what is the story? You know, are these observations part of a larger program? This is part of giving the context, but this can also be a part of, say, an observational context of, you know, you have data from ALMA that you're supplementing, or you have an observation with the JCMT that you're digging deeper in. You're proposing to use the SMA here. Why should why use the SMA? Make it clearly about the SMA, right? Just as, you know, if you write a job application, you know, why should you come to this place and not to that place? The more you know, the more you share about your depth of interest and knowledge in that, the better. You know, what experience do you have with the SMA? What experience do you have with interferometers? Not looking for your CV here, but demonstrations that that you can do these things are useful. Will you make good use of the data? Do you have a track record of publishing observations? That's always good. And then one of the challenges, you know, that review committees always see some proposals that are what we would call high risk, high reward, and some which are steady progress of, you know, we're going to do a few more objects in this sample, as opposed to, you know, we're going to try something completely different. And all observatories like to have a mix of both of those. Steady progress, you can guarantee that papers will be written, fields will be advanced. High risk, high reward, maybe a whole new field opens up, or a whole new kind of object becomes a target for the telescope. And so you know, there are different strategies for each of those kinds of approaches. Some of the tools that you want to make use of here, your title and your abstract. You know, your busy reviewer is going to get a list of titles. Is going to get and is going to look at the abstract first, and so a well-written abstract that makes clear the overall thrust of the program, what's going to be observed, why it's going to observe, what questions it will touch on, can carry you a long way. You know, good figures are really incredibly important to draw out the underlying concepts and demonstrate your mastery of the data and the techniques. Bullet lists, itemized lists, often very useful to call out specific things, as well as things like using good uses of headings, italics, boldface. You want to stay away from jargon if you can. You know, we're scientists and we work in our subfields, and so that means there's definitely jargon, but try to keep this at a level that, you know, someone reasonably well versed won't have to go look up that acronym that you're using. At the very least, define the terms that you're going to use. You want to do a good job with references. You don't want to overload your 2-page proposal with references, but you want to show you know the past work in the field and the context. You know, if someone's reading your proposal on star formation, there's a good chance that they've written some papers on star formation using the SMA, for instance. And part of what those reviewers will look for is, you know, does this person know what I know about the field? And then there are the tools, the sensitivity calculator, calibrator catalog, data archive. The data archive is really key. You know, make sure that your target hasn't been observed before in the mode that you want to observe it. You know, don't go writing a proposal when you could just go and get the data all on your own and have it now, not 6 months from now. Okay. As with all writing, there are so many mistakes. This slide itself is a bit of a mistake. There's too much information in this slide. Don't try to pack too much in. You know, don't shrink your fonts. Don't violate the proposal guidelines on sizes or margins or things like that. Keep your figures relatively simple. Make them readable but explanatory. Source selection. If you're doing a sample of objects, or even just doing one object, why did you choose that one? If you don't explain that, that's a red flag. What caused you to choose that one source? You know, technical errors where you have the sensitivity wrong by a significant factor, or you're inconsistent. You say you want the compact configuration in one part, and you say you want extended in the other, or you want compact, but you want 0.1 arc-second resolution. Don't overpromise. You know, be sure to deliver a focused question, right? Again, people want to know, what is the story? What are we going to get out of this at the end? Okay, so as an attempt to share with you, you know, how to do this, this is a proposal that I've written for the SMA, and I tried to break it down here and show some of the different aspects of it. So variability timescale of low luminosity AGN, pretty simple title. You at least know what direction this is going in from that. There's some big picture kinds of statements in here. Variability in black hole systems is a critical diagnostic. Black holes in general relativity are scale free. There's a multi-wavelength context that we give here: optical wavelengths, X-ray, millimeter, radio. We narrow as we go into the proposal here in the third paragraph, we're narrowing it down. What is our specific problem? And we're pointing to a paper that our team wrote, Dexter 2014, one of my co-investigators on this proposal. We put some jargon in. We need the jargon because that's part of our science, but we explain it. We define it, we explain it, and we try to so that we write that out so that it's clear for the reader what we're doing. We again emphasize our work and making use of the SMA. We show results, and then we come back to that big picture. The submillimeter comes from very close to the event horizon, right? So that's, why observe the submillimeter? Well, it's coming from close to the event horizon, and that's a really interesting region. Then we have a specific plan that we propose. What sources are we going to observe? Again, this is a steady progress proposal. It's building on previous work, so we have some preliminary results that we can share. And then what are we going to get? Here's a focus question. We're going to test this particular relationship, and then again we link this program to the Event Horizon Telescope. Presumably, people are excited about that, and excited about how jets work in these systems, big picture, big context kind of issues. And then a specific plan, technical justification here. What kind of sensitivities do we need? How long do we need to observe in order to get them? What's the total time request in the end? What configuration do we need? Can we observe in what weather conditions? And so anyone reading this knows what we need, what the array needs to be able to do to be successful. And the figures. There's a lot of, a lot of the story is told in the figures. So in the upper left, figure 1 here, the big picture. This is that correlation that I referred to, and connects our new targets with Sagittarius A star and M87, very famous targets. We show examples of how our analysis works, what kind of constraints it places on the parameters that we want to measure. And we show data that past data that we've obtained with the SMA. So we prove it. We reduced our data. We put the references in a pretty compact form here. You don't need to write in the title. You don't need to write in a lot of detail. You don't need to put a lot of space into it, but you want to show that you're knowledgeable about the field and the broader context. Now, of course, I'll point out one of the ways in which we were very successful with this campaign. We generated a lot of data until the point at which we weren't, because we fell behind in analyzing our data. And then the TAC said, well, we'll give you, this is a great program, but we'll give you more time once you've reduced and published your data. And we're working on that. So that's, you don't always succeed, even with good proposals, unless you've done all of your homework. Okay, my proposal was turned down. Now what? It happens to everyone. So don't despair. Read the reviewer comments, but don't take them as gospel. Don't take them as the ultimate truth or argument about what you're doing. But consult with your fellow students, postdocs, colleagues, group members, get other readers, rethink it, revise it, resubmit. Sometimes the reviewer didn't get it. Well, maybe that means that not that your idea is flawed, but just that you need to tell that story a little bit differently, or sharpen a particular point, or make a better figure, and then come back, resubmit, and you have a good chance for success. Okay, so here at the end, just a few practical details. This is from a couple of years ago, but when you're proposing, get the array status, the technical information. What can you propose for? Create an account, keep track of deadlines, think about, are you doing a large scale project or a small scale project? Here's the data archive, right? So you want to go here, you want to search this for your particular object and see if it's been observed before. And maybe it has been observed, but with not enough sensitivity. Well, if you have the time and you can reduce that data and show, that it didn't get to the sensitivity that you wanted, that's a huge plus for your proposal, because it shows you're committed, it shows you're knowledgeable, it shows you've done your homework, and reviewers will respond to that. The sensitivity calculator, of course, really critical for planning your observations, giving you, an estimate of how sensitive your measurements will be, what your UV coverage will be, what your synthesized beam will look like for your proposed observation. And then you can look at the spectral line distribution for your configuration in the event that you're a spectroscopist. I am not a spectroscopist, so I have very little familiarity with this particular tool, but clearly it's a useful tool for planning and exploring the different receivers and the correlator tunings. And then finally, there's the Calibrator Database, and I just show you one very interesting object there, but this is part of how you make your overall plan of selecting good calibrators. Put the name of your calibrator in there, into your technical justification. It takes a sentence, and it shows that you've dug into the problem and demonstrated that you know how these observations will work. So if you do all of those things, I can't guarantee that your proposal will be successful, but those are good steps to follow in order to have a successful SMA proposal.